Welcome to section 7.5, which are all about partial fractions. Now, if you're going to use partial fractions, kind of says so in the name right there, you've got to have a fraction. Now, what's going to separate this from a U substitution or an inverse trig function is the denominator has to factor. You're always going to start off hoping that it's a U substitution. If that doesn't work, then you're going to try either your improper fractions, a trigonometric substitution, partial fraction. Partial fractions, the denominator has to factor. All right, so these are the steps that we're going to use when we have decided we have a partial fraction experience. Okay, so the first thing we're going to do is make sure that our fraction is proper. So if you have a numerator's power that is bigger than the denominator's power, you are always going to start off and divide. And that is pretty much in any case, whether you've got partial fractions or U substitution or anything. Power on top's bigger, divide. Then you're going to factor the denominator, because really that's what sets partial fractions apart from inverse trig functions, is that you can factor the denominator. Now for the BC test, you're going to encounter linear factors only. So that means you're going to have x to the 1 powers. You're not going to have x squareds. So you're going to factor them all. Each factor you're going to put under a letter of the alphabet. Okay, so A over the first factor plus B over the second factor plus C over the third factor, and so on. Now we're only going to have to deal with non-repeating linear factors. So linear factors, no x squareds. Non-repeating means all of these factors are going to be different. Okay, so after you get it all set up, you're going to multiply by the least common denominator. And then you're going to figure out what A has to be, what B has to be, what C has to equal, and so forth. So basically, you have this simplified fraction. We are going to pull it apart into what it used to be before you found the common denominator, before you found the equivalent fractions. So we're pulling the fraction apart, but we've got to figure out what the numerator used to be before it all canceled. Then you're going to rewrite each partial fraction, and you're going to integrate. Note, you're going to have something over x, so you're going to have a lot of natural logs in your future. So let's look at the first example to see exactly what this is going to look like. All right, so our first example, we have 1 over x squared minus 5x plus 6. Now when I look at this, I'm thinking, oh, could I use a U substitution? No, because in order to have a U substitution, I'm going to need to have a 2x minus 5 somewhere in the numerator, and I just don't have it. So U substitution's out of the question. Now I might think I could complete the square and try to get an inverse trig function, but look at what you have on the bottom. If it factors, you're going to use partial fractions. And x squared minus 5x plus 6 does factor. So that's what I'm doing. I'm going to factor. That gives me x minus 3 times x minus 2. I'm going to rewrite it with a letter on top of each individual factor. So x minus 3 was my first factor, so I'm going to put a over it. Plus, I'm always going to use plus, b over the next factor. And then I'm going to multiply by the least common denominator. So I literally multiplied both sides by the LCD. Okay, so this side over here, that LCD canceled with everything on the bottom, so that's how I got the 1. Okay, when I multiplied this side by the LCD, okay, the x minus 3 canceled, so I just had the x minus 2. On this fraction, the x minus 2 cancels, so I had the x minus 3. Now I need to solve for a and I need to solve for b. Well, if I want to solve for b, I need to knock a out of the picture. Well, I know that a is multiplying by x minus 2, so if I choose x equals 2, that's going to give me 0, knocking out my a. So that's what I'm going to do. I'm going to pick values for x that are going to give this guy equal to 0 and this guy equal to 0. Okay, so my first point, I picked x equals 2, because if I put 2 in for every x, my a is going to be multiplied by 0. So the left side, there aren't any x's, that's why we still have 1, equals a times 2 minus 2, which is 0. and then plus b times 2 minus 3, which is negative 1. So I end up with 1 equals negative b, so b is actually negative 1. So this fraction up here, it's negative 1 over x minus 2. And we're going to rewrite that in a moment. Now we're going to look at where the other factor is going to equal 0, so we're going to pick 3. So if I plug 3 in for all of the x's, I end up with 1 equals a times 3 minus 2 plus b times 0. Well, b times 0 is 0. A times 3 minus 2, that's 1, so a equals 1. So we're going to rewrite. Okay. So this was a, so we have a 1 over x minus 3. This was b, so we have negative 1. Notice that's a negative now. Okay, so we just took that negative. And now I get to integrate that. You're thinking about integrating both of these at the same time. So you're literally thinking about each of these. Now when you're thinking about integrating these, I want you to think about your little u substitutions. Sometimes you may not need to do a u substitution, and sometimes you will. For instance, on this, I know my u is going to be x minus 3, so du is going to be just dx. So this becomes du over u. So when I integrate that, I'll actually get the natural log. Okay, so when I integrate that, I'm going to end up with the natural log of x minus 3. Same thing here. If I do a u substitution, I'm going to have x minus 2. My du is going to be dx. So this guy is going to look like du over u. So when I integrate that, I get the natural log of the absolute value of 2. Okay. Don't forget your plus c. Alrighty, so using your partial fractions, okay, you can make this a nicer experience. So let's look at one example from scratch, from the start. Okay. So when I'm looking at example 2 here, sometimes it's not very difficult for us to simplify, and we will appreciate that. All right, so the first thing we're going to do is we're going to factor that. So that's going to be, actually to save time, I'm just going to put x over x plus 1. So I factor the denominator, okay, and then I'm going to get everything set up and ready to go. Okay, so this is x times x plus 1. So I'm going to take 2x plus 1 all over x squared plus x, and I'm going to set that equal to a over x, the first factor, plus, and I'm always going to use plus, but whatever b's sign turns out to be, that's, you know, what's going to drive the original. Okay, and then x plus 1. So these factors, I made it addition, and now I just need to figure out what a is equal to and what b is equal to. So if I multiply by the least common denominator, which is x times x plus 1, I'm going to end up with 2x plus 1 equals, I'm going to have a times x plus 1 plus b times x. So I want to think about what x values are going to cancel out this a. Well, a is being multiplied by x plus 1, so I'm going to use negative 1. And I'm going to just change the color. So to get rid of a, I would look at when x is equal to negative 1. So when I do that, I'm going to have to put negative 1 in for this x, and for this x. So I'm going to have 2 times negative 1. Okay, so I'm going to have 2 times negative 1 plus 1 equals a times negative 1 plus 1 plus b times negative 1. So 2 times negative 1 plus 1 is negative 1. This cancels, that gives us 0. And then you have negative b. So b turns out to be 1. Okay, so at x equals negative 1, that helps me figure out what b is equal to. Now I need to find out what a is, so I need to cancel b out. Well, if I put in x equals 0, That's going to help me knock out the b, because then I'll have 2 times 0 plus 1 equals a times 0 plus 1 plus b times 0. So I'm putting zeros in now for all of the x's. So that's going to give me 1 equals a. Wow, that was fast. So I'm all ready to write it all out. So I have the integral, and I'm going to have a is 1. So remember how a was over x, so now it's going to be 1 over x, plus b. b turned out to be 1, so 1 over x plus 1. All of that. Don't forget your little dx in there. So if I split this up, I need a dx in both. This one is natural log of the absolute value of x. There's no u substitution needed. This little guy, I will need a u substitution. You're going to get to the point where you don't need to write it out, but until you get there, please feel free to do so. So that's going to give me the integral of du over u. So when I integrate that, I'm going to end up with the natural log of the absolute value of x plus 1 plus c. Now they might get kind of fancy on us in our answers. If you have a free response problem, you're more than welcome to leave it as is right here. But remember, with logarithms, you can take 2 logarithms and join them together as a single log. If they're added, you know you can bring those together as multiplication. If they're subtracted, you can bring them together with division. The negative guy is on the bottom. So you may see either answer. Multiple choice, sometimes they like to simplify, sometimes they don't. Okay, so just be aware of that fact. Okay, let's try another. All right, so looking at this, let's see if we're getting the idea of it all. For x squared minus 9, that does factor. Okay, it factors 2x minus 3, 2x plus 3. So I'm going to rewrite it. Okay, you've got 1 over 4x squared minus 9 is going to equal your a over 2x minus 3 plus b over 2x plus 3. Doesn't matter which one you put over which one. If you have a over 2x plus 3 and then b over 2x minus 3, it's all going to work out in the end, so please do not panic. All right, so I'm going to multiply by the least common denominator. So LCD and LCD. When you do that, you get to this point. Now, if you want to just go ahead and get to this point, that's perfectly fine with me. And then b times 2x minus 3. Okay, so you're thinking about numbers that are going to cancel one of them out. So you're going to check at x equals negative 3/2 because that'll knock out your a, and at x equals positive 3/2 because that's going to knock out your b. Now what's nice about it is you've got a 1 on the left side, so 1 equals, well, negative 3/2 times 2 is negative 3 plus 3 is 0, so the a's gone. Then you come over here, you have 2 times negative 3/2 minus 3. So you literally have, and let me write it out, I don't want anybody to get confused. And then plus b over 2 times negative 3/2 minus 3. So this is going to be 0, and this is going to be 6, negative 6. So that's gone. So b is going to be negative 1/6. Okay. So if we do the same thing at x equals 3/2, I'm going to have 1 equals a times 2 times 3/2 plus 3 plus b times 2/3 or 3/2 minus 3. Okay, so that's 0. So I have a, Okay, so I have 6a equals 1, so a is going to equal 1/6. Okay. So when I rewrite it, let me rewrite in black. I'm going to be taking the integral of a, which is 1/6, over what a was, 2x minus 3. Okay. And then minus, or plus rather, I'll do plus. And then b is negative 1/6 over 2x plus 3. Okay, add your dx, add your dx. Okay, now we're going to simplify this a little bit. I'm going to pull that 1/6 out in front, and then I have 1 over 2x minus 3 dx minus 1/6, 1 over 2x plus 3 dx. Now when I'm looking at this, I'm just going to show you one of them because it works the same way. So if I look at this guy right here, if I do a u sub, I'm going to need to use 2x minus 3. So that means du is going to need to be 2 dx. I don't have a 2 dx, so I need to put the 2 in. I need to multiply by 1/2 out in front. I'm going to be doing the same thing for the second integral, so it's going to look very much the same. So what's going to happen is I'm going to end up with 1/12, and then the integral of, let me write it over here. Oh, mercy. Let me just rewrite. So I'm going to have du over u. So when I integrate that, I'm going to have 1/12 natural log of the absolute value of 2x minus 3. So I'm going to have that same thing happen here. So if I were to do a u substitution here, I would have the 2x plus 3. My du would be 2 dx. I don't have the 2. So that's going to be minus 1/12 du over u. And then of course you have your plus c. Now once again, remember, they may write this as one handy dandy little guy here. If they take the 1/12 out, and let me see if I can't just scrawl this on here just as nasty as I can. If I take the 1/12 out, I'm going to have this natural log minus this natural log. Remember, subtraction means division. The negative guy is on the bottom. So they may also have this as our answer, which is perfectly lovely. Okay, here we go, kids. Rocking and a rolling. Okay, our next example. Okay, actually I want you to work this one out and see what you get. Okay, I'll put the answer down at the bottom of the slide. If you have any problems, let me know. The answer you should get would be 2 natural log of the absolute value of x plus 3 minus natural log of the absolute value of x plus 1 plus c. And you can write those together if you want to as a fraction. So try number 4. This is the answer you should get. Let me know if you don't.